Welcome to my channel. In this video, we want to look at electrical energy and electrical power. Electrical energy and electrical power is what we are looking at this morning. Let's look at the learning outcome. Learning outcome. In this video, you will define electrical energy. You will understand what electrical power is all about. You will explain the relationship between electrical energy and electrical power. Then you will be able to solve problems on electrical energy and electrical power. And lastly, you will understand the importance of electrical energy. Electrical energy is one of the forms of energy. In my earlier video, we looked at sources of energy and different forms of energy. So I encourage you to watch that video so that you have more information about what we are looking at in this class. Electrical energy is produced when electron moves or flow freely through a conductor. When electron moves or flow freely through a conductor, what we produce is called electrical energy. And it is transmitted from one point to another by means of a wire or conductor. Or we can say electrical energy is the work done when a quantity of charge moves between 2 points of potential difference. So mathematically, we can say that electrical energy is work done equal to charge, quantity of charge, times potential difference. So we can say that work done equal to charge times potential difference. Let's call this equation 1. And as we all know, current is equal to charge times time. So we can say that quantity of charge is equal to current times time. Let's call this equation 1. Let's call this equation 2. Work and energy are effectively the same because we say that energy is defined as the ability to do work. So we can say that work and energy is the same. So by that we can say, write our equation 1 to be work done equal to energy, quantity of charge. Let's call this equation 3. The unit of work is joule. The unit of energy too is joule. Okay, we have seen what electrical energy is all about. Let's look at electrical power. What is electrical power? Electrical power is defined as the rate at which work is done or energy is transferred into an electrical circuit. So electrical power we say is defined as the rate at which work is done or energy is transferred into an electrical circuit. So mathematically, we can say that electrical power is equal to electrical energy over time. So we can say that electrical power is equal to electrical energy over time. And from here, electrical energy will be equal to power times time. So let's call this equation 4. So we have seen the expression for electrical energy and also for electrical power. Let's look at the relationship between electrical energy and electrical power. From equation 1, or we can say from equation 3 here, we can say that work is equal to electrical energy is equal to QV. But electric power, P, can be expressed as IV. So if we call this equation 5, and if we put this equation 5 into equation 4, we will have that work or electric energy will be equal to PT, which will be equal to IVT. Let's call this equation 6. This gives us another relationship between electrical energy and electrical power. And also from Ohm's law, we have that V is equal to what? IR. So if we put in place of this V, put this IR, we can write equation 6 as work equal to energy equal to I square RT. Let's call this equation 7. And also, from here, if we make I the subject formula from this Ohm's law, V equal to IR. If we make R subject formula, we have V over R. And if we put this into this equation 6, we will have work to be equal to energy and equal to V square. In place of I here, we are putting this. So V times V, you have V square. Then this T and R. Let's call this equation 8. So from here, we have established relationship between electrical energy and electrical power. This is the first relationship, that electrical energy is equal to electrical power times time. So if you know the electrical power, know the time, you can compute electrical energy. Then also, knowing that electrical power is equal to IV, if we substitute here, we got another equation, equation 6. So from here, we can compute electrical energy. If we know the current, know the voltage, know the time, we can compute electrical energy. I hope you are following. Then also from Ohm's law, we can use equation 7 to compute electrical energy. If we know the current, know the resistance of the conductor, know the time, we can compute electrical energy. And also, equation 8, we can use it if we know the voltage, the square of it, the time, and also the resistance from the resistor. We can compute electrical energy. So these are the expressions that we can use, and based on this, it has given us information about the relationship between electrical energy and electrical power. So let's use all these expressions to solve some problems. Okay, example 1. Let me read out the question, then we'll solve it together. Calculate the electrical energy produced by a heater with a voltage supply of 220 volts when a current of 10 amperes passed through it for 5 minutes. Solution. The first thing to do here is to get information about the given parameters. So let's look at the given parameter, the given data or parameter. From the equation, The current given is 10 ampere. The voltage supply is 220 volts. Then the time is how many minutes? 5 minutes. So we need to convert this 5 minutes to seconds because the SI unit of time is seconds. So all you need to do, multiply by 60. So if we multiply, we have 300 seconds. We are to find the electrical energy. And from the given parameter, we know the current, we know the voltage, the time is known. So we can use this formula to compute the electrical energy. So let's substitute. The current is 10, voltage 220, then the time 300. So if you multiply and you simplify, you have 660,000 joules, which we can write 660 kilojoule. So this is the electrical energy. I hope it's not difficult. All you need to know, understand the equation, bring out the given parameter, check the formulas, the one that have the given parameters. Then the next thing is mathematics. You substitute, simplify, and the answer will be there for you. Okay, let's look at another one. Example 2. Let me read out the question. Calculate the energy in a lamp with a resistance of 4 ohms when a current of 5 amperes passes through it in 150 seconds. Solution. We know the current to be what? 5 ampere. The resistance is what? 4 ohms. Then the time is what? 150 seconds. So check among the whole formulas that we have gotten for the relationship between electrical energy and electrical power. Based on this parameter, which one do you think we will be using? Okay, write it down. Let's see. Write it. What do you have? Yes, compare this with your own. Is this what you have? Okay, let's substitute and see. Current 5 ampere, resistance 4, time. Substituting and simplifying, we have what? So this is the electrical energy. If we express it in kilojoule, that is the answer. So this is the electrical energy supplied by the lamp. I hope it's not difficult. Okay, let's look at other example. Example 3. The question reads, what is the terminal voltage that expends 135 joules of energy to move 15 coulombs of charge around an electrical circuit? So this is another question. Can you try it? Let's see. Okay, let's look at the given parameter. We know the energy to be what? 135 joules. The quantity of charge is what? 15 coulombs. Which expression do we use? Using the expression. Which expression? We have established that work done, which is equal to electrical energy, is what? QV. If you remember, from the definition of electrical energy, it says the work done in moving a unit charge, moving a charge particle with a potential difference. So this was our equation 1 when we started. So from here, we are looking for electric potential. So let's make V subject formula have E over what? Q. So let's substitute. You have 135 over 15. So simplify, let's see. The answer is 9 volts. So is it difficult? No. Bring out the parameters, think of the formulas to use, substitute and simplify. Then the answer is there. Okay, let's look at one more example. Example 4. Let me read out the question. 100-watt light bulbs illuminated on for 1 hour only. How much joules of electrical energy have been used by the lamp? Solution. Let's bring out the given parameter. Electrical energy is what we are looking for. Electric power is what? 100 watts. And it was used for 1 hour. So we need to convert the 1 hour to seconds. So in 1 hour, we have 60 minutes, we have 60 seconds. So 60 by 60 will give us 1 hour. So we will have 3600 seconds. So the next thing now, which formula do we use? We know the electrical power, we know the time, and we are looking for electrical energy. So electrical energy is equal to electrical power times time. Is that taken from the definition? So let's substitute. Electrical power is 100 and the time 3600. So let's simplify. So we can express this 360 kilojoule. Is it difficult? No. So these are calculations on electrical energy and electrical power. So I believe they are not difficult. So let's make progress. We want to look at generation of electrical energy. Earlier, I told us that electrical energy is one form of energy that we all know. And like every other energy, say energy can neither be created nor destroyed, but can change from one form to another. So let's see how we can generate, how we can create electrical energy. Electrical energy can be created. Electrical energy can be created from the following sources. One, from batteries. We can create electrical energy from batteries, from generator. This is another way where we can create electrical energy. From dynamos, from photovoltaic, and many others. So this is how we can create electrical energy. Through the use of battery, we can create electrical energy. Through the use of generator, through the use of dynamos, and through the use of voltage, photovoltaic cell, we can create electrical energy. So, creation of electrical energy. So how do we store this energy? Storage of electrical energy. So we can store electrical energy for future use using the following: fuel cell, Through fuel cell, we can store electrical energy. Also, through batteries, we can store electrical energy. Through capacitors, we can store electrical energy. And also through magnetic fields. And through other means. So these are the various ways in which we can store electrical energy. So based on the conservation of energy, the energy can neither be created nor destroyed, but it can change from one form to another. One can say that electrical energy can be either created or stored. And these are the ways in which we can create electrical energy. These are the ways in which we can store electrical energy. I hope that is taken. The next thing we want to look at is importance. Importance of electrical energy. Electrical energy has several importance over other forms of energy, and that is what we want to look at. The number one importance is convenience. Electrical energy is a convenient form of energy. So let's look at it. So electrical energy is very convenient. It can be easily converted to other forms of energy because of its convenience. For instance, if you want to convert electrical energy into heat, all you need to do is to pass the electrical energy through a high resistance wire. Example, heater. So if you pass electrical energy through a high resistance wire like heater, you discover that it will be converted from electrical energy into heat. So one of the importance of electrical energy, like I just mentioned, is its convenience. The second one is easy control. Easy control. Electrically operated machines have simple and convenient starting and control operation. For instance, you are operating a machine, it's an electric motor. You can easily start it or stop it by just turning on or off the switch. So by that, it means electrical energy is very easy to control, unlike other sources of energy. The fourth one, greater flexibility. This is another importance of electrical energy. So electrical energy is very flexible. It can be easily transported from one place to another with the help of a conductor. So if you have electrical energy at this point, you want to transport it to another point, all you need to do, just with your conductor, it can easily be transported. So the other importance or advantage is greater flexibility. Then the third one, the fourth one, is cleanliness. Cleanliness. It is not associated with smoke, with fumes, or with poisonous gas. Hence, it ensures cleanliness and healthy condition. So as electrical energy is flowing through a conductor, no noise, no smoke, no poisonous gas is emitted. So because of that, it is a clean energy. Okay, let's look at other one. The other one is cheapness. Cheapness. Electrical energy is more cheaper than other forms of energy. Thus, it is overall economical to use. It is overall economical to use this form of energy for domestic, commercial, and industrial purposes. You see why electrical energy find its application in everywhere, at home, in the industry, in the commerce sector, everywhere. Electrical energy is very, very important because of its cheapness. Then the last one here is high transmission. High transmission efficiency. Electrical energy has high transmission efficiency. It can be transmitted conveniently and efficiently through long distance from the place of generation to consumers with the help of overhead conductors, which we call transmission line. So when electrical energy is produced at the point of generation, through the help of a step-up transformer, the voltage can be increased and it will be transmitted through the use of overhead conductor over a long distance with minimal power loss. So we can say that electrical energy has high transmission efficiency. So thank you very much. So far, we looked at electrical energy, electrical power, and we try to understand what each of them is all about. And we also looked at the relationship, the mathematical expression relating electrical energy and electrical power. We equally solve some problems as well. And we looked at creation of electrical energy and how we can store electrical energy as well. Then we looked at the importance of electrical energy over other forms of energy. Thank you very much for watching. Please like, share, and subscribe to my channels for more interesting videos.